Hi friends, a very good evening and thank you for joining in. Could you just confirm in the chat window if I'm audible and visible and if everything is working as expected? I typically try to join a few minutes early. I got a little delayed today, but thankfully I'm just on time. So could you just confirm if everything is working all right? Okay, cool. So we'll get started in a minute or so, right? I'll as usual, I'll spend some time, roughly about half an hour at the end in Q&A. So, okay, everything is working as expected.
Roughly about half an hour at the
Okay,
end.
so that's just my phone. Sorry. So cool. Let's get started then. Okay, everything is working fine. Good. Okay, without any delay, let's get started so that we can spend some more time at the end in Q&A. So I'll just start sharing my screen. Give me a second, please. Okay. Is my screen visible and audible? Can you just confirm that? Is my screen visible and am I audible? Let's start with the questions quickly today. I promise you I'll spend enough time in Q&A at the end. Okay, so today's live session is all about a bunch of concepts from engineering and discrete math, specifically combinatorics and calculus. Again, these topics have little less weightage in general, but especially combinatorics can be combined with probability. And calculus, typically you see 1 or 2 marks of questions, right? So, cool. So let's get started with the very first question. So here is our first question of the day. Again, please put your answers in the chat window so that everything is on track. And as soon as a decent number of you have answered, I will go into the solution itself. We'll start with the easier questions and slowly increase the complexity as we go. A basic combinatorics question here. Typically a 1-mark question. In case you're not seeing the chat window, just refresh it. You'll see the chat window. In case there are some people who joined little earlier and who are not able to see the chat window. Please put your answers in the chat window so that I know that a decent number of students have answered, and then I'll explain the solution. Again, please, since this is a numerical answer type, feel free to use a calculator that you have on your computer or a physical calculator that you have. Please try to put in the numeric value here, the number. Please try to think from first principles instead of being formulaic. The best way to solve problems in combinatorics is to solve from first principles. That's what we also try to inculcate when we teach combinatorics at Applied Gate course. Solve from first principles. I see a few answers. Please revisit your answers. Everybody who has put in the answers till now, please revisit your answers. The question is very clear. How many numbers can you construct using 1, 2, 2, 4, 6, 6, 6, which are greater than 3 million? I see a huge variance in the answers. Everyone who has put in an answer, please go back and revisit it. This is an easy question, guys. To be honest with you, a lot of 11th and 12th class students can comfortably solve this. This does not require anything more than 11th and 12th class combinatorics. Doesn't require anything more complex than that. This is by all means an easy question by gate standard. But I'm surprised that a lot of you are getting it incorrectly. Again, questions like these could also be asked in aptitude rounds of many companies, right? Especially the product-based companies, and also some services-based companies for higher compensation roles. I'll wait for some more time because I'm hoping some of you will correct your answers. Again, please don't ignore combinatorics. It is so fundamental even in the applied aspects of computer science. It is a foundation for most of probability. I mean, you count so many things in CS in general. So this question is all about just arranging these numbers. I see some of you get the right answer, but a vast majority of you, I think, have the wrong answer. Again, I see a lot of students who are in a hurry to answer typically get wrong answers. So take your time, for heaven's sake. I thought 90% of students would get this answer correctly, but I'm wrong. Anyway, cool. Since we have many more problems ahead of us, let me try to solve this. So you have this number, which is 3 million, right? Now let's go position by position. And how many numbers do we have? 1, 2, 3, 4, 5, 6, 7. There are 7 locations and we have 7 numbers. It's as simple as that. So which means in this location, what all numbers can you place? Because you want numbers greater than this. So if you want to construct numbers greater than this, in this position, there are 2 possibilities. You can either place 4 or you can place 6. Any other number you place here will result in constructing a number which is going to be less than 3 million, right? So now let's go and think from first principles again, right? So you have 4. So if let's assume you place 4 in the first digit, how many possibilities are possible now, right? So for example, if you place 4 in the first digit, literally you have 7 digits, right? So look at this, you have literally 7 digits and 7 numbers. Suppose you placed 4 here, you're left with 6 more locations, right? In these 6 locations, what all numbers do you have? You are left with 1, 2, 2. The 4 is already taken up, 6, 6, 6. These are the 6 numbers you have. You can place these in any order because the first number 4 itself is greater than 3. So if whichever way you place these 6 numbers or 1, 1, 2 2s and 3 6s, you can place them in any way. In how many ways can you arrange these numbers? Again, this is nothing but arrangements with repetitions. So there are 6 locations, so 6 factorial ways, but there are repetitions here. There is a repetition of 2 twice, so place 2 factorial here. There is a repetition of size 3. Right? So place 3 factorial. This is simply number of ways you can permute with repetitions. It's as simple as that. So if you evaluate this, if I'm not wrong, this is equal to 60. Again, correct me if I've done some calculation mistake. So the other possibility is you place 6 here. There are only 2 possibilities, right? So if you place 6 here, all the values that you get here will be different from the possibility of if you have placed 4. So the moment you place 6, what all numbers are you left with? You're left with 1, 2, 2, 4 and 2 6s you're left with. And now you need to place these 6 numbers in these 6 locations. In how many ways can you do it? Again, you basically have 6 factorial ways, and on top of it, 2 is repeating twice, 6 is repeating twice. So this becomes 2 factorial, 2 factorial. And this is equivalent to 180, right? So what is the total number you have? You have 60 plus 180. And they're completely disjoint sets. Because once you're starting with 4, the numbers that you get are different from the possibility of starting with 6. So the total that you have are 60 plus 180, which is 240. This takes less than 30 seconds if you're thinking from first principles, right? Again, I'm very happy that some of you who have taken time thought through from first principles. This is not a rocket science problem. Again, in a lot of combinatorics, please don't overthink. Try to solve problems from the very basics like these. Again, you can actually derive this also. Oftentimes, I don't even remember this formula, but I can derive it from first principles in an examination setup. Again, as somebody like me who is very, very bad at remembering facts or formulae, I mean, this is super duper easy. It's a typical 1 mark question by GATE standards. Easy question. Okay, so with that, let's go to the next question. Again, a combinatorics problem. Please read the question carefully. Again, think from first principles. Don't try to apply formulae because you might misapply it. This is an MCQ because nothing else has been stated here. This is a very typical GATE question. Sometimes it could be asked for 1 mark, but very often it can also be asked for 2 marks. Again, this could have been given as an numerical answer type, and this is in between easy and medium. Right? Some people might consider it medium, some people easy, but yeah, take your time. It's okay. Take your time. Think from first principles, please. Good. I see some of you putting in your answers. Good job. Here I'm very surprised. How come people are getting this more correctly than the previous one? Probably we should have just given it as an NAT, letting people go and do a wild goose chase. Anyway, I'm happy that people are getting the right answer. Very happy about it. Again, those of you who have answered this question, can you tell me why this was easier for you than the previous one? Please feel free to put it in the chat window. Oh, cool. Sadiq says we got attentive after the first question. Thank you. That's good. Good, good, good. Okay, cool, cool. Sunidya says in the previous question he overlooked the repetition case. Good. Yeah, that's very, very important. Repetitions you have to be very careful with. Aarti also agrees that the first question, people after making mistakes in the first question, she got more attentive. Good, good. I'm happy. It's the improvement that matters. Very good. Aniket, good point. Yeah, so I think first question people missed out on the repetitions and made silly mistakes. This, they're more careful. I'm happy to see that. You have to be always attentive about repetitions. I'll wait for a few more seconds. Again, my way of solving might be different from what others have solved, because the way at least I personally solve, that I also enjoy solving combinatorics problems, are from first principles. I try to think from, okay, what is happening here? That way I don't have to remember formulae, and I'm terrible at remembering formulae. Anyway, let me answer this question for those who are still not figured it out. So if you just start counting here, you have two p's, right? You have a p here, you have a p here, right? You also have two r's, right? So you have two p's, two r's. What about e's? You have two e's here, right? Then what about o's? You have two o's here, and you have two s here, and then you have one t and one u, right? Now of these, if you look at vowels, right? A, E, I, O, U. So what all do you have? You have O, U, E. So you have two E's, two O's and one U, right? In how many ways can you arrange these vowels now? Straightforward. You have 5 values with 2 repetitions. So this is as simple as 5 factorial by 2 factorial into 2 factorial. You can arrange these vowels in 30 ways. I hope I didn't mess up my math. Yeah, because everybody got answer SC, so I hope I didn't mess up the math. I make some of these silly mistakes where I write the equation correctly, but I'm in a hurry to do the math and I make mistakes. That's one of my biggest weak points with respect to making silly mistakes. So we know vowels, right? So what about consonants? I think they're called consonants, or I think they're called consonants, right? Consonants. Or else whatever, non-vowels. If I got this wrong, I forgot whether they're called consonants or non-vowels, whatever, okay? Let's look at all the non-vowels, right? So this is a vowel, this is a vowel, this is a vowel. Let's look at the non-vowels of the consonants. I think they're called consonants. How many of them do you have? 2, 2, 2, 1. So you have 7 of them. So in how many ways can you arrange them? 7 factorial by how many repetitions are there? 2 p's, 2 r's and 2 s. So 2 factorial, 2 factorial, 2 factorial. This is, I've done this math earlier, this comes to 630. Now the way you can easily think about it is, okay, so you have say 630 ways of creating consonants, you have 30 ways of placing vowels, and you want all the vowels to be consecutive, right? So which means if you think about it, imagine if I have consonant 1, consonant 2, consonant 3, so on, so forth, consonant 7. Now if you think about it, where all can I place my, suppose imagine I concatenate all of these vowels, right? Imagine I concatenate them and I'll place them as one single block, right? Where can I place that block? I can place it here, I can place it here, I can place it here, so on and so forth. I can place it till here. So there are a total of 8 locations amidst the consonants where I can place this whole block of 2 E's, 2 O's and 1 U, because I want all the vowels to be consecutive, right? So now if you think about it, okay, so in how many, so let's go step by step now, right? So in how many ways can I place all these 7 consonants? I can place it in 630 ways. So let's write that. First I've placed the consonants. After I've placed the consonant, there are 8 places, there are 8 locations where I can place my my brick or my block of vowels. These 5 vowels that I have, I can place in any of the 8 locations. Now after I've placed it, suppose imagine I chose to place here these 5 vowels. In how many ways can I now place these 5 vowels? I can place them in 30 ways. So if I just do this, what does that turn out to be? 630 into, sorry, 630, oh my bad. Okay, something, okay, just give me a second. So that is 630 into 8 into 30. That's 151200, right? So that's it. So C is the right answer. Again, this is how I think about it. I'm sure some of you have some formulaic approaches to do it. Nothing wrong with it, but I personally prefer this foundations way of thinking because this will help me build the skill in case there is no formula, right? Very simple, right? Very simple strategy, very easy strategy. Cool. So somebody is saying this might be a slow approach. Yes, I agree with you, but I would rather be slow than make a mistake, because gate examinations, if you have strong foundations, is never a fight against time. It is mostly a fight against, it is basically a measure of skills and knowledge and foundational stuff than time. Again, this whole problem, the method that I have solved it, because I've solved it earlier in the evening, I could solve it in less than a minute if I'm not wrong. Okay, so it's not that hard. It doesn't take time even if you're doing from first principles. Okay, sounds good. So with that out of the way, let's get into some calculus. Okay, for those of you who don't know what is an integral part basically means if you have 2.3, the integral part of it is 2, right? The integer part of it, that's what it means. In case you don't know what it means, don't get confused with integrals. Oh, Sahil, it's okay, Sahil, even if you're slow, that's okay, man. What we need is accuracy at this point. Speed will automatically come. Again, there are some general questions. Gautam, feel free to ask the same question at the end. I'll happily answer that, okay? Because your question is very helpful even to others. Again, there are some follow-up questions about the first question. Mentors, if you're here, can you please answer those follow-up questions just so that the flow is not disturbed for the rest of them? Okay, let's solve it now. This is a very nice problem. I enjoyed solving this problem. This is an MCQ. This is a problem between easy to medium. I would rate it as easy, but some people might rate it as medium because most CS folks are not comfortable with integration and limits and calculus in general. It's a good 1 to 2, 1 mark typically, maybe 2 marks also sometimes. But this is a simple problem. I see some of you putting in your answers. Good. Yeah, let's focus on solving the questions, folks. I'm thinking, is there a hack to solve this problem? Okay, so I think students are mostly getting A and C as the answer. When I was solving it, I got A as the answer. Let's see both. If x lies between 0 and 1, okay, let's solve it anyway. Let's solve it and see, because I see most students either picking A or C. Okay, let's solve it. Let me show how I solved it earlier, right? So if you have x, right, this integral part of x, if you think about it, it lies between x minus 1 and x. That's what it lies between, right? So I mean, I'm just trying to see if I can come up with it, because there are these possible. This is how I solved it. Again, we'll see other solutions also, obviously, right? So x minus 1 is certainly going to be less than this. Is it true if x lies between 0 and 1? Just let me, if x lies between 0 and 1, let's just take an example. If x is, let's say, 0.9, right? So, okay, this lies between x minus 1, which is going to be 0.9, right? Yeah, so this lies between, okay, this value is 0, we know that. So this lies between 0.9 and 0.9 minus 1, which is minus 0.1. Yeah, so this also holds true, right? So this also, again, I'm just trying to see if I have made a mistake somewhere. So let's go through this. So this is one thing that we have. The other thing here is, if you take 2x, right, the integral part of 2x lies between 2x and 2x minus 1, right? It lies between this. This is commonsensical, right? Now similarly, I can keep going on. The reason I'm going into this direction, the reason I got this thought process was, there is a denominator n square here. I want to somehow cancel this n square. And if you think about it, if you know the sum of the first n numbers, right, the sum of the first n numbers is this. There is roughly an n square term there, right? Again, in limits you cancel out numerators and denominators, right? That's why I went down this path myself. Similarly, if you have 3x, right, 3x lies between 3x minus 1 and 3x, right? So on and so forth. You can keep going on, and you can say, hey, nx lies between nx itself, or the integral part of nx lies between nx. You keep going on and say, hey, nx minus 1. Now a simple strategy which is often used in math is sum up all these, sum up all this, right? The inequality will still hold, right? So if I sum up all this, what do I get? I get x plus 2x plus 3x plus so on and so forth. And what would that be? That would just be, if I take x outside, if I take x common here, right, I get 1 plus 2 plus 3 up to n. And that is nothing but n into n plus 1 by 2. Of course, there is also minus 1, minus 1, minus 1 repeating itself n times, right? So there is obviously minus n there. This is what, if I sum up all this, if I just summate all this, this is what I get. So I can say, hey, this is less than equal to this summation. Okay, I'll just let me write it this way. I equals to 1 to n ix. I'm just writing the short form, the summation of all these, right? And what will this be less than equal to? If I sum up all this, what would I get here? If I sum up all this, I will just get x into n plus 1 by 2. Right? Simple logic, right? So if you think about it, again, I'm just trying to get an inequality and try to work with that inequality. Again, different people might have solved it differently. Let me explain my solution. I got answer as A, but we'll see if other answers are also possible or correct. Okay, so with this, right? So again, I'm not making any assumptions about x. All these statements are true, whatever x is, right? I've just added this, so I get this expression now. Now, once I get this expression, let me just erase this so as to just create space here. Now, if I just erase this, now what can I do here? Very simply put, I can just divide this by n square, because I know that n is, the n is surely, n tends to infinity. So I'll divide this by n square, right? I will divide this by n square, I will divide this by n square, right? Simple. Now, if I divide this whole expression by n square, by n square, by n square, right? Because then whatever is there within this limit, this expression, I got it here. Right? That's what I'm getting. I'm trying to do an upper bounding and lower bounding type of exercise. Now, if we do this, what happens then? Let's see. So let's go step by step and be careful with this. So you get x by 2. Let's remove the x by 2. Then you have, so you have n square plus n minus n. You have x. Let's go step by step. You have n square. So here, what do you have? I'm taking x by 2 out. You have n square plus n divided by n square. So that becomes 1 plus 1 by n, right? Minus, you have n by n square. So that becomes 1 by n. So this is going to be less than equal to this expression, right? So whatever expression. So let me just write it as summation ix by n square. This is going to be less than equal to, so take x by 2 out here also. So if I take x by 2 out, I have n square plus n by n square. So this will become 1 plus 1 by n. Now as n tends to infinity, again whenever you have these things, this 1 by n will become 0, this will become 0, this will become 0. So what are you left with? You are left with, as n tends to infinity, this whole thing. Okay, let me just not cut it off. As n tends to infinity, this whole thing is lower bounded by x by 2. It is also upper bounded by x by 2. Right, look at this. As n tends to infinity, it is lower bounded by x by 2. It's also upper bounded by x by 2. Right, which means it has to be equal to x by 2. Right, that's how I arrived at A as the answer. And this is true irrespective of what the value of x is. Did I make a mistake here? Just to be clear. Did I make a mistake anywhere? I just want to be careful because some of you got C also as the answer. I just want to be careful there. Again, this is a non-trivial question, to be honest with you. It's not trivial, right? Because again, this on this function, look at this. What is this function that you're applying? It's called the integral part, right? You can't just apply other techniques because integral part is not a simple continuous function with all the nice properties. So, and again, these types of functions, the integral part type of function actually occurs in computer science because we take floats, seals, we take seal, floor, round, right? All of those are very similar to this, right? If you think about the logical part of it. So this is how I arrived at x by 2. So even if x lies between 0 and 1, the answer is still x by 2. It will not be 0 because I made no assumption about any value of x. Whatever math I've shown works for all values of x. Oh yes, that's true. Spandan, you're right. These types of functions are also very popular in IIT JEE because I believe these types of questions were actually set by the computer science folks because these functions actually occur in computer science. Okay. Again, some of you may have applied L'Hopital's rule or also referred as L'Hospital's rule, but that, I mean, this function is not your typical function on which you can easily apply that, right? So it is better to go, again, this question is tricky, no doubt about it. That's why I said earlier that some people might think of this as a medium level problem and this could be asked as a 2-mark question. It's not going to be an easy problem, and problems like these are very, very common or at least commonly seen in IIT JEE. We understand that, right? Cool. Sounds good. With that, again, actually, to be honest with you, the GATE computer science calculus questions are easier than IIT JEE. Okay. I'm not saying the same thing is true for mechanical, civil, electrical folks because they have vector calculus, but for CSE folks, whatever is here is quite simple in general. Okay. With that out of the way, okay, here is a slightly lengthier question. Okay, so this is a typical 2-mark question. Please take time. This question is lengthy by design. This is a medium level question. It is going to be lengthy. So take your time. Don't worry. We just want to prepare you for the slightly harder questions. If I have to give a hint, look at the options provided and use it to direct your solution. That is a faster way for problems like this because there are already 4 solutions given to you. Use them. So use the options given to direct your solution. Without these options, this can become a lengthier problem. Imagine the same question was given with some bounds A and B, right? And given as an NAT. That would have been harder than using these tricks. Please use the options given to direct your solution in the right path. This took me about 3 minutes to solve, if I'm not wrong, about roughly 3 minutes, but I could only solve it in 3 minutes because I used these options. I used the solutions to direct me. Otherwise, it would have taken much longer. That's the advantage in objective type paper. One second. F2 equals to, sorry, is there an error somewhere here? Just give me a second. I'm just looking at my notes also to be sure. I think there is a small error somewhere. Just give me a second. I think this should be -1 and not -3. Can mentors, can you just check this please quickly? I think it should be -1. One second. F0 should be -3. Okay. F1 should be -3. I'm just cross-checking it because I think in my notes I solved it slightly differently. Probably I made a mistake copying the question. Just a second, please. Yeah, so there is a small typo here. I'm sorry. Apologies for that. But you can still solve it. The answer may not change significantly, but okay. I've just changed the values of F0, F1 to be equal to -3, F2 equals to -1. There is a small typo when I was copying these equations. Yeah, that may not change the answer as much because the direction will not change significantly. By the way, there is no AB here. Those of you who have solved it, maybe you can teach me a shortcut if you have a shortcut, because I solved it the long form. To be honest with you, I didn't know a shortcut to this except for taking help of these options themselves. Is there a shortcut that you applied that I did not know? Or I would love to learn, to be honest with you. That's the reason why I'm asking if you know a shortcut. Those of you who answered quite quickly. Okay, that's a nice strategy. Substitute 1. So how would you substitute that 1? I'm also thinking of a strategy. Can I do some? Yes, so the way I'm thinking, as one of the anonymous students says, is can we just differentiate the expression given and the expressions given? Yes, that's a strategy that I was thinking of actually. It's easy to, anyway, let others solve it anyway. Yeah, eliminating between option A and option B is slightly tricky because they're very, very close. Okay, let me think of an alternative strategy. I solved it the long form when I was solving it earlier. Okay, yeah, I think anyway. Somebody is saying if I substitute 1, it will give me infinity. So let's assume you substitute x equals to 1. This becomes denominator 0. That's an undefined quantity. Okay, with that, can we eliminate some of these? Not exactly right. It's not that easy. How can you be 100% sure about eliminating at least 3 of the 4 options using some hack or trick quickly? Anyway, let's discuss that a little later. I'll wait for others to put in your answers. Again, please don't get confused between infinity and undefined. They are 2 different things. And infinity is not the same as undefined. Division by 0 is undefined. It's not infinity. A lot of people mix that up. There are 2 different concepts in mathematics. And infinity does not behave like infinity plus infinity infinity doesn't behave like a regular real number. It's a very special type of number. And there is a whole field in set theory where you learn about infinite number of infinities. So infinity, there is no one type of infinity. There are infinitely many infinities. That is Gregory Cantor's work in set theory. So okay, so let me solve it. I know the solution that at least I have solved earlier is slightly lengthy, but let's go into it step by step, right? So if you see the question, we are told that we have a quadratic expression, right? So what we have, your fx is a quadratic expression. So it is ax square plus bx plus c, right? And there are 3 facts given to you. One is f0 equals to minus 3. You're also told that f1 equals to minus 3 and f2 equals to minus 1. So you have 3 unknowns, a, b, c, and you have 3 equations. So it should be fairly straightforward to compute what a, b, c are by just plugging in. right? So if you plug in x equals to 0, what do you get? You get only c, right? So you get only c, and c is equals to -3. So we got c equals to -3. Simple, problem solved. Now if you plug in x equals to 1, what happens? You get a plus b, right? You get a plus b -3, because c will be there. -3 is equals to -3 itself. So you cancel these two, then you get an expression which says, hey, a plus b equals to 0. You still have to find a and b. So if you plug in x equals to 2, what do you get? So you get 2 square is 4, so you get 4a plus b is, you don't know what b is, so x equals to 2, so you get 2b plus c. C you know is -3 is equal to -1. So if you now add +3 to both sides, right? So this becomes 0, this becomes 2, right? So what do you have? You have 4a plus 2b equals to 2. 4a plus 2b equals to 2. So divide both sides by 2, you get 2a plus b equals to 1. So you have 2a plus b equals to 1, a plus b equals to 0. So if you solve these two, you can easily arrive at a equals to 1, b equals to -1. Very simple. And you already know that c equals to -3. First step. So now you have the whole fx equation. So let's write the fx equation first. So your fx now is, so the integral that you want to compute is x square minus x minus 3. And the reason for that is a is 1, b is -1, c is -3. Divided by x cube minus 1 dx. Now first thing that you have to recognize here, at least the way I solved it was, I saw this x minus 1 and x square plus x plus 1. The same thing I've seen this here also. Okay, there is this x cube. I mean, like if you think about it, log basically, if you're integrating this, you have to get 1 by, right? The derivative of this, derivative of log x is 1 by x. So if you think from that perspective, the hint that I got from this is, okay, let's try to break this x cube minus 1 into these two, because it easily fits into that narrative, right? So the first step that I've done here is I said, okay, let's break it down. So can I break it down as, I can write my x cube minus 1 as x minus 1 multiplied by x square plus x plus 1. The beauty of it is that fits exactly into this narrative, right? So that fits exactly into these expressions. Again, I'm taking hints from these expressions as I'm trying to solve it myself. Now I said, okay, so let's break it down. If I want this expression, I need to get 1 by x minus 1. If I want this, I need to get something by x square plus x plus 1, which means I need both these terms, and there is an addition to these. So now I need to decompose this somehow. So the simplest way that I remember decomposing it is, okay, so again, this is same as this, so I can just erase this and write it as x minus 1 into x square plus x plus 1. Again, some of the math that I learned in my 11th and 12th class, I said, okay, let's write it down. So when I solved this, when I tried to factorize this and split the numerator into two parts, I got this. This is what took me a little time, because I'm not used to solving this like a 11th, 12th class student. Plus 2x plus 2. It took me a little bit of tinkering around to get this, but it's straightforward. So now the advantage that I have is I can break this sum into sum of two integrals. Now things are looking neat for me, because if you see this, right, I can write this as 1, I can just multiply numerator and denominator by -1, and this fits into this narrative, right? And this is, if you think about this, of course there is 2x plus 2. I would like to preferably break it down into 2x plus 1, and then also have 1 by x square plus x plus 1, because this 2x plus 1 is the derivative of this, right? Look at this. This is the derivative of this. So if I write this as u, this is du. Of course, there is dx always. Okay, I just skipped that. There is dx always. So now this is getting me into the territory that I want, where I would want this to be in the log form, right? So now if you see this, so from here, okay, this, if you take the integral of this gives me this part. Okay, let me just erase this. So just quickly saying, so this gives me, the integral of that is this, right? So next thing here is, if I write this as u, right, then du is this, right? And this gives me again the log term when I integrate it, right? So that gives me this term. So both these terms are done. So with that I said, okay, I can eliminate c, I can eliminate d, they're not going to matter. But then the third part was, okay, I still have to choose between a and b. Now there is a arctan or tan inverse, right? So the first thing that I recall is where does arctan come in, or tan inverse? It's also called as tan inverse or arctan. Typically, it comes in this, from what I recall from my calculus classes, is if you have this, right? So if you have something like a square plus u square, right? The integral of this is 1 by a tan inverse. Again, some books call it as arctan, some books call it as tan inverse u by a plus c. This is where I see the tan inverse coming in the integrals from the formulae that I remember studying. Now my question was, okay, here is what I have. Can I somehow get into the tan inverse form? Because this part is resolved, this part is resolved, I'm only left with this. So how do I play that game given that I know already this? Again, remember, this is du, there is u square and a square. So of course, the next step that you can quickly think of is going to look like this. So what do we have? We have 1 by x square plus x plus 1 dx. This is what we have. So I said, okay, I'll try to break it up into some, again, there is du, some function of x squared plus a square. Let me just break that down. And when I try to break this down, I can write it as 1 by, again, integral obviously, x plus half squared plus 3 by 4. Now the beauty of it is this, again, I have dx here, but the beautiful thing with this is I can think of this as u squared. I can think of this as a squared in this formula, right? Because again, if you think about it, if you have x plus, so what happens here? X plus half is your u, right? And you have du here, and the derivative of x plus half, right, is equal to dx, right? So if I try to map these things, what do I get now? Now if I solve this, again, look at this. What is 3 by 4? If this is my a square, here I get 1 by a. So what will 1 by a look like? If this is a square, right? So a will be root 3 by 2, right? So then what will 1 by a look like? 1 by a will look like 2 by root 3, right? So can I get an answer with that? Yes. Without even solving the rest of it, I know that the 1 by a will look like 2 by root 3, and here I have 2 by root 3, here I have 1 by root 3. So obviously this has to be the answer. Of course, I went one step ahead to make sure that I'm not making a mistake. There is also 2 by root 3 here, and that makes sense given that a is root 3 by 2. So 1 by a, because there is a here, right? There is a in the denominator, right? Which means this a will take the shape of 2 by root 3. This a will be root 3 by 2 because it's in the denominator, will become 2 here, root 3 in the numerator, right? So I just took the hints from the actual options given to figure out that a is the right solution. Couple of things that I needed on my way were two simple facts. One is, whenever you have this sort of setup, you get log as the integral. That's the first useful formula in calculus. The second useful formula was this, right? That when do you get tan inverses in your integration? You get tan inverses when you have this sort of setup. So it was mostly about mapping things. Imagine if somebody didn't give all these options and gave some range A to B and said, hey, this is an NAT, that would have been much, much harder, much, much more time taking for sure, right? So this is the approach that I've solved. I'm sure there are other approaches. One approach that others were solving was, yeah, this is lengthy. I mentioned this at the earlier also. Actually, to be honest with you, this is not that lengthy if you're taking the hints from these places. Like when I was solving this, the way we do it is my team of mentors, they create some of these questions. They give me a set of questions. I try to solve these questions without looking at the solution. This took me about, I think, roughly about 3 minutes. And the only reason I could solve it in 3 minutes is by taking the hints from these answers, right? So a question like this most likely will be like a 2-mark question, considered mostly medium and certainly lengthy for sure, right? This problem is not hard. I think some of you are mistaken that this problem is hard. No, it's not, because the reason it's not hard is this is a very popular formula. Where do you get tan inverse in your integrations? And the next obvious thing is, where do you get logs? It's not hard if you know the basic formulae for different integration. And finding fx is straightforward, right? It's just about plugging in the values. It is not lengthy if you know how you're tackling it. Okay, it is time consuming. I agree with that. It's not hard. By gate standard, it might be called medium, but it's just slightly lengthy. I agree to that. Okay, here is another question from Combinatorics. This will be the last question of the day, after which we'll have Q&A. This is a question from Combinatorics. Typical gate type question. Just read the question carefully. That's the important thing here. And solve from first principles. I think there is a formulaic approach to solving it. If you know that well, please do it. But I would rather solve it from first principles because I'm bad at formulae. And I often misapply them even if I recall them. So somebody is saying, what do you mean by when you say solve by first principles? It basically means try to think, okay, I'll explain that when I solve it anyway. That might be better. Start from the basic stuff. Okay, I'll tell you that, Subdeep. I'll answer that question when I explain this solution. This is a decent 2-mark question by GATE standards. Just read the question carefully, it's all there. We've also given the options to be slightly on the easier side. Yes, so there is a question here. Is it compulsory for all voters to vote? Yes. Because it says that there are 30 votes, right? So which means these 30 people have voted. Again, there are a few general questions. I'll surely come to that in a while. Please feel free to post them after this question is over. Okay, good to see people putting in their answers. Good to see that. Harsh, you're right. It's like the placing sticks example that we provide in our course videos. That's how I also think. That's how many of our mentors also think. You're right. Good to see many of you getting it right. Okay, I'm happy that people not getting the right answer in the first question was just about overlooking a few things. I'm happy because I was really concerned with the first question. Cool. Just in the interest of time, let me answer this question for you. So we know that there are 30 votes, right? And the number of election outcomes that are possible, which means number of votes for different candidates. And if you see this, let's assume this is the first person. Let's write 30 numbers, right? Not the first person. That's not what I mean. Suppose imagine you just write these 30 numbers. or you can just place some bunch of sticks for every person, right? You can just place these sticks, 30 sticks for like 30 people for each person. And now we can say, hey, where can I place, because there are 3 candidates. Remember, there are 3 candidates, right? And there are 30 people who have voted, right? Now imagine I want to place a separator, right? Imagine if I place a separator here, let's assume I place a separator here. Then all the numbers that are here, there are 2 votes. Let's assume these 2 votes went to candidate 1, right? Suppose there are some 15 votes here, okay? These 15 votes could go to candidate 2, and the rest, whatever are there, they went to candidate 3, right? So the problem becomes all about, imagine if I have 30 sticks, where can I place these 2 separators? And all I need is actually 2 separators. I don't need 3 separators, because when I place 2 separators in these, amidst these 30 sticks, I get 3 regions or 3 counts. This is 1 region, this is 1 region. I get the distribution of the 30 votes amongst these 3 candidates. So again, when somebody asks me, what do you mean by first principles? I know some people who have a combinatorics formula. I forgot what that formula was also, to be honest with you. Some people remember a combinatorics formula and say, hey, 30, I want to distribute 30 amongst 3 people. So there is some formula like n plus k, something. I don't even know that formula, to be honest with you, because very likely if the problem is changed slightly, I might misapply it. So I would say, let me think from first principles. Let's take this simple example. This is how, by the way, the formula that you're talking about, some n plus k, something, some choose something. I don't know what it is exactly, by the way. Okay, I don't even bother remembering it. So there is a formula like this, and that is derived using this approach. So I would rather go to this fundamental thing instead of a formula very often, because I'm bad at remembering formulae, number 1, because I'm bad at this. And 2, even if the problem is changed slightly, I can play this game because I know how things are arrived at in the first place. That's what I mean when I say thinking from first principles. Think from the very basic concepts, right? Okay, so now look at this. I have 30 sticks. In how many places can I place these 2 separators? Because when I place 2 separators, I get 3 results, 3 counts to 3 candidates. Now, if I have 30 sticks like this, I have 32 positions, because I have this position also, this position also, right? I have a total of 32 positions. In these 32 positions, I can choose any 2 positions. I can choose any 2 positions to place these arrow mark separators. So I have 32 choose 2 ways in which I can break these 30 votes amongst the 3 candidates. Of course, the candidate might get there will be some configurations where candidates will get 0 votes also. That's perfectly all right, right? So what is 32 choose 2? If you just work out the math, it comes to 496. So obviously A cannot be the right answer, D cannot be the right answer. 496 is A, right? That's what I mean when I say think from first principles, right? This is my approach, helped me all throughout these years. Now, so A is 496, we already have it. What about B? It says, additionally, if some candidate receives a simple majority, which means he exactly receives 16 votes. So you have 3 candidates here. So you can pick any one candidate in 3 ways. So pick one candidate. You can pick that candidate in 3 ways. And that candidate got 16 votes. Okay. Now, you are still left with 14 votes. These 14 votes, you need to split them across 2 candidates now. Look at this. You can pick the winning candidate in 3 ways. Now you have 14 candidates. You still are left this winning candidate. The winning candidate got exactly 16 votes. So you're still left with 14 votes. These 14 votes you need to split across 2 candidates. Again, this is exactly the same matchstick problem, right? So you have 14 sticks here. Now all you have to place is just one separator, right? You just have to place one separator, and once you place this separator, you get whatever the remaining 2 candidates, how many votes each of them got. And how many ways can you do it? You can do it in, I think, 15 ways, right? So if you think about it simply, so you can do it in 15 ways. But you should remember that in 15 ways, you can split the vote between the losing candidates, and the winning candidate can be chosen in 3 ways. So the total number of ways you can distribute the votes across these 3 candidates will be 3 into 15, which is 45. So B is 45, A is 496. It's simple as that, right? That's why I'm happy that many of you got it right. Very happy to see that. And let's go to the cam view. Again, let me just get all the questions here. That will be easier for me to answer. Just a second. Okay, so cool. Okay, I have the questions here. I also have them on my phone in case there is a glitch. So there was one question a while ago. I asked that learner to also put that question down a little later. So the question here is, how do I practice more? So my suggestion, again, there are two aspects to it. The first aspect itself is, if you are already solving everything from the practice tests, the 2 test series and previous year questions going at least 10 years back, you're already solving I think you're solving like 7,000-8,000 questions across GATE. That is more than sufficient. There is a mistake that we see students commit, which is they pick one subject, they solve too many problems in it. That doesn't help, to be honest with you. Because then what happens is you're going to spend 2 months just solving combinatorics or calculus or that. You have to weigh your time smartly based on the weightage of marks given to various topics in GATE. Please don't fixate on one thing, because we've seen people just spend 2 months just on C programming and they would never finish the syllabus. It's impossible, right? So make that informed choice that you're going to practice and put in effort proportional to the weightage of a subject or a topic in GATE. That's very, very important, number one. Number two is, when you're solving the problems, some people might say, hey, I've exhausted all the problems. But if you've solved these problems rigorously, when I say rigorously, I mean solving a problem doesn't mean you give it 5 minutes and then you look at the solution. Sorry, you have not solved that problem. And if I change that problem slightly or change it or twist it slightly or reword it, most likely you will not be able to solve it. You have to go through that process of building the problem solving skill, which is you spend the time on a question, you're not able to crack it. Again, retackle that question after maybe a few hours or maybe the next day. And when you're not able to even solve, then learn what you're missing. That constructive process of building the problem solving mindset is the must. And even in combinatorics, even if you solve 50, 60, maybe 100 problems, right? More than sufficient. And all the problems that you've seen solutions in the past, please go back and try to retackle them. Don't remember the solutions. Try to solve the problems. Even if that is over, you can pick up any standard textbook at 12th class level. Take any IIT JEE textbook. You have tons of problems about combinatorics, and those are pretty good, to be honest with you. There are literally tens of thousands of problems in combinatorics in IIT JEE, because IIT JEE has a lot of weightage for that, right? So, but you don't have to go to that extreme, to be honest with you. Okay, cool. So what is the best way to attempt questions in the examination to maximize the number of questions solved? So I would say there is no one right strategy there. We have seen students apply their own strategies, but try to learn one strategy that works for you. Broadly, these are the strategies that people do, which is they iterate through all the questions, whether it is easy, medium, 1 mark or 2 mark. They try to solve all the questions in the first iteration, whatever they could solve. Right? Whatever they are comfortable solving, whatever they are not in a doubt, they will just go solve it. In the first iteration, imagine if you have solved like 50-55 marks worth of questions. Then in the second iteration, you can also tag a question and say, hey, this question seems easy, but might take a little time. I want to come back, and when I'm coming back, I want to prioritize these questions. So first iterations, people read the questions, everything that is straightforward, easy questions, they solve it. Again, easy could be different for different people, right? For example, math may be very easy for me, and maybe computer networks might be slightly harder because I don't remember the packet formats, right? So it depends from person to person. Whatever is your easy subject, whatever are your easy topics, solve all of them. Second iteration, come back and solve those where you have a fairly good chance of solving. Those hard ones, just ignore. You don't have to, right? If you're not sure, if you're sure, go ahead, solve them. This is a strategy that works reasonably well in practice. And you can start practicing this when you're taking grand tests, full length tests, mock tests, all of that. Like we have a ton of them, right? So try to refine a strategy that works for you, because each of us think differently. This is how at least I did myself when I was a student. We have seen a lot of toppers follow a similar strategy, not the same strategy sometimes. Okay, cool. Very nice question. This is, how do we avoid the mistakes that we have done in the very first question? I think in the first question, probably people didn't read the question or overlooked it. The lesson that everybody who got the first question today wrong, the biggest lesson that you should take care of is, please go write down, literally write down and say, hey, this is a mistake I made. I didn't think of repetitions. go back and read, make a note of that. That's very, very important, right? If you make a note of it, you will not forget it next time. Again, making mistakes in preparation are good because you're going to learn what not to do in the final exam. I think most likely people were like, "ठीक है यार, easy question है. That's a short question, easy है, so let me tackle it. It's not going to be hard." So people were overconfident, which is extremely dangerous in GATE, especially if the question is slightly twisted. So just make a note that, okay, in combinatorics, I will look for repetitions. Okay, that's a mistake that you will not forget the next time. It's good to do mistakes here because you learn what not to do. So Sarthak says, I want to prepare for GATE. I'm in the 4th semester. Which course duration is better for me? Sarthak, since you're already a second year student, my suggestion to you is try to target to crack GATE in your 3rd year because you can take it in this year. Again, depends on very often we do see some second semester students starting their preparation for GATE, and that's perfectly all right. Just make sure that you're covering the subjects that you have in the course curriculum rigorously. So for example, in your course curriculum in your second sem, let's assume you have operating systems. Start that operating system in second semester itself. Typically 1 year duration would be sufficient, but again, you can reach out to us on the phone and talk to one of our mentors or one of our co-founders and ask any follow-up questions. But yes, you can do it, but just make sure in your preparation strategy that you're focusing on the subjects that you have in the coursework in your second semester, because there's no point messing up your regular coursework. You can always mix GATE prep with this, and overall it's going to be better anyway, because GATE typically is at a higher standard than most universities. Okay, cool. So this is Smriti who says, I'm a 3rd year student. I'm left with 3 subjects, but I face difficulty in completing computer networks. I was literally in your shoes in my BTech 3rd year, to be honest with you. And that's okay. That's okay. Maybe what you want to do is, if you're stuck in computer networks, just keep it on the back pedal. Probably you want to take a look at it after a month when you're a little fresher and finish the other 2 subjects that you have. You can come back to computer networks at the end. If you're feeling a subject is too hard and you're not making significant progress, don't get stuck. Say, okay, this is what I've done. Let's assume you have solved, you've already covered to some extent. Finish that, go to a different subject, finish the rest of the subjects and come back to the topics where you're stuck. Don't get stuck at a specific topic for too long. Computer networks, I understand. Again, computer networks was one of the harder subjects for me, especially in my BTech 3rd year when I was writing GATE, because it was not yet covered in my course curriculum. We had computer network in the final year during my BTech days. So it was harder because I had to learn everything up front or before even I learned it in my coursework. Number 2, I'm bad at remembering formats of these packets. That's where I messed up a lot. Then I came up with memory tricks to remember some of those. But this happens to all of you. Don't worry, 3 subjects, you're on a very right track. We are still in early August. You're on track, don't worry. Just finish the rest of the subjects and then come back to CN. Again, somebody's asking that they have a problem with undecidability. Don't get stuck on a topic for too long. That is the essence. If you feel a topic like undecidability is too hard, it's okay. You've given it a try. Don't get fixated on it. Move to the next subject. Maybe you get 1 mark or 2 marks from undecidability, leave it. It's okay. I understand I should not encourage people to leave topics, but you also have to be realistic given the vastness of syllabus in GATE. There will be some topics in which even faculty members who actually create the GATE question paper would not be good at. Let's be realistic there, right? So it's okay. Don't get stuck. That is the key. If you're getting too much stuck on any single topic, especially like topics like undecidability, it's okay. Take a chill pill. Put it on the side, make a note that you have to come back and revise this later and go to the next subjects, right? Undecidability is slightly harder to score than other topics in TOC. That's perfectly all right. Again, I'm happy that some of our mentors are also answering these questions. Cool. Yeah, so somebody's asking about one second. Spandan, is there a problem in the solution that we have done? Again, if there is any problem, just cut a ticket. We will update the answer. If somebody saying, why are there 32 places to place separators? Because you have 30 locations and you have 2 separators, no? You have to place all these separators like that. Anyway, if there is a question, feel free to cut a ticket. We will answer that quickly. So don't worry about, again, feel free to just, because again, I have to go back and explain a concept which most students got. So just in the interest of everybody, because I also want to answer some general questions, please feel free to cut a ticket. We'll give you the elaborate explanation, I'm sorry. Yes, again, somebody, Elias AP says, hey, I'm little stuck in synchronization. Guys, the simple logic is this: don't get too stuck on any topic. If you're feeling that you're too stuck, nobody, even the toppers in GATE or even the professors who set the GATE question paper, are not good at every topic, right? There are some topics that I struggle with, like computer networks, packet formats. I struggle with it. I have to double check, triple check. Like some of the closure properties, right, in TOC, I don't remember them. That's why I have these memory tricks through which I remember, because if I have to prove them, I might be able to prove it if I spend 10-15 minutes on it, but we don't have 10-15 minutes in examination, right? So all of us struggle through that. There is nothing to feel bad about, but all the topics you're struggling, please put them on the side, keep moving. Okay, there is some ad, right? Some alcohol company, something like that, right? So keep moving. So please do that. Cool. So should we write whole code when doing DS and C programming, or only, so one second, I didn't understand this. So there is some question about programming, right? I'm just seeing it on my computer. Let me just zoom in on my computer because I'm not able to see these comments clearly. So the question is all about, should we write whole C code while doing DS and C programming, or only hints? Again, if you have time, there is nothing better than building that programming skill. It is super duper useful. It's a life skill that will stay with you. So all the algorithms, if you can write C code or C++ or Java code, great. If you don't have time to do it, at least write pseudocode. At least write pseudocode, because it's a form of revision, right? Again, we explain all these concepts with pseudocode the way it's taught in Introduction to Algorithms by Carmel Leeserson. At least write pseudocode. If you have time, if you're preparing for placements, please write code in any of the major programming languages. Cool. So what about change in syllabus in GATE 2022? We are still reading the document. We want to be 100% sure before we tell you that there is. But at least in our first initial scan, we didn't see a huge change in terms of syllabus or the format. But again, please don't take my word for it, because it's a lengthy document. We want to double, triple read it just to make sure that we have not missed any specific detail. So most likely even if there are changes, they'll be very minuscule and small. Okay, cool. Again, syllabus changed last year, so the likelihood of the syllabus changing this year significantly is like very, very low probability. So somebody saying we have about 5 to 6 months now. What could be a good revision strategy and test series strategy? Again, for your first iteration, I mentioned this in almost all the live sessions. In the first iteration, the strategy is simple: weekly revision, monthly revision, quarterly revision. When you're revising, please take tests, right? Once you finish the first iteration, second iteration, revise all the subjects once, start taking the grand tests. Okay, mock tests I think we'll have mock tests from sometime in September, if I'm not wrong, the all India mock tests and things like that. Start taking the grand tests that you have in the previous year test series and this year test series. I mean, that's a lot. But after you take every test, every full length test, debug your mistakes, go back, revise. So between every 2 tests, especially grand tests that you're taking in a second iteration, make sure you take the grand test, make a note of all your mistakes, go back, revise those topics which are not confident, again, then take the next text. So debugging process and revision process has to be interlaced. I think that's the word in computer networks, right? It has to be interlaced with your exam taking. So your second iteration is typically full-length tests, revision, debugging your mistakes, going back, revising. Again, oftentimes you know which topics you're less confident. Go back, revise those more rigorously. Third iteration is, okay, I've done enough practice. Most likely this is what you'll do in the last 2 to 3 weeks, maybe 3 to 4 weeks. Revise everything once, revise all the mistakes that you've done, make sure you don't do it, and start preparing for the final exam. This is a typical strategy that we recommend. A lot of students follow it. And of course, students have their own strategies. I'm not saying this is the only right strategy. This is one of the good strategies. Cool. Again, somebody is talking about competition. We don't care about competitors, we care about our students. Again, this is a very important lesson that I personally learned at Amazon. Amazon is extremely customer centric, not competition centric. We learn from competition, but we don't care too much about them. We only care about how best we can deliver to our students. Cool. I started GATE preparation. This is from Sai. I started GATE preparation 5 months ago. I'm currently in my 3rd year. Should I focus GATE or coding skills? Sai, you have a huge advantage that you're still in your 2nd year. You're still in your 3rd year, I'm sorry. So do both. Why say this versus that, right? Since you're in your 3rd year, try to prepare as much as possible. Write the GATE examination this year. Or you can say, hey, I will also prioritize those subjects like C programming, data structures, algorithms, databases, operating system, etc., which will also help you get placed well in your final year, right? So please don't say, especially if you're in your 2nd or 3rd year, please don't say GATE versus this. Please code. GATE and coding has to go hand in hand. I think we published a video on how not to prepare. I hear a lot of feedback from some of the most senior faculty at universities like Indian Institute of Science and IIT that, dude, most people who come in through GATE are not able to write code, which is very, very unfortunate. Then I tell them and say, hey, introduce coding into GATE exam. That's it. The solution is simple. You guys control how the exam is conducted, right? Just introduce coding. I wish they do it. I really hope they do it. A lot of institutions, even in Institute of Science, they're conducting coding tests after filtering candidates through GATE before they get admitted. It's a nice thing because coding is so fundamental to every area of computer science. You have to be good coders as CS graduates or people who are writing the GATE exam in CS. So please don't say this or this, please do both. Because you're in a 3rd year student, you have a lot of time. Cool. No, Abhishek says, sir, while revising, should we go through our notes or give the test and analyze? No. So let me tell you the steps. First, revise all the notes. Revise all the mistakes that you have made in your previous practice tests or subject tests. Revise your notes first. That's very important. Then take the test. Second step is take the test. Third step is debug your mistakes from the test. Improvise your notes based on that. It's a very simple 3-step process. Revise all your notes, revise all your previous mistakes, take the test, debug your performance. 3 simple steps. Because if you don't revise and take the test, most likely you'll not perform well. Right? So somebody is asking about TOC, how to think with the problems. Again, please check out some of the live sessions that we have done for theory of computation, where we discuss about strategies on how to think. Again, in many of these live sessions, even the combinatorics that we have done today, right? My focus was not just about solving 5 questions. It is mostly about how to think from first principles in combinatorics. Similarly, in calculus, one of the things that we tried to do in today's session itself is how to leverage the options, how to take advantage of the options that are there to solve the problem, right? These are important strategies. Similarly, we have discussed similar strategies in almost every live session that we have done. So please go back, they'll be there on our YouTube channel. Please check them. We discuss specific strategies, even common mistakes, because I remember in TOC, I still remember it very vividly. There was one problem where I tried to just use my intuition and not check all the options. I made a mistake in the live session itself. So that was a great lesson that, okay, don't overthink it. Think of all the options. Don't try to come up with generalizations and make mistakes. So again, please go through those live sessions. I enjoyed them a lot, especially in the context of teaching how to think. Okay. Cool. So this is from VR who says, I'm little lost how to get back on track. Simple logic. Tell yourself that from tomorrow, you will sit X hours in the morning or X hours in the evening, write a schedule and say, like one simple strategy that I often employ is, I don't either have my breakfast or my early morning snack or fruit or whatever it is till the time I spend 2 hours finishing something early in the morning. Simple. Right? Very simple strategy. So fix time, work in that time, and once you finish that job, treat yourself with a snack, with breakfast, with whatever you like. Simple strategy. You have, like, you will not, getting back is not, like, it will not happen without you putting in that disciplined action. And you'll actually only start seeing results after putting in that consistent effort for at least a few weeks. That's the way it is. So which device do you use to write on screen? I use this very basic Wacom tablet. I've been using it. I mean, You can just Google search for it. It's just a basic Wacom tablet. I use this extensively. I've been using it for years and I love it. It's very affordable. I think a couple of thousand rupees if I'm not wrong. One of the best investments, for me at least. Okay, so Balaji says, I'm a second year student, how to start math? First and foremost, I don't know if you're in second year, second semester. Yeah, this is second semester time, right? Again, you must have already studied discrete maths and engineering maths. Just go through the notes. Again, if you're starting your GATE preparation now, you already know the basics. You have studied them in your regular university coursework. So it must be quite fresh in your mind. Just tackle them. Like, I don't know whether you're preparing for GATE or not, but just make sure you focus on the discrete maths part, especially concepts like graph theory, concepts like combinatorics, probability, Bayes theorem. These are stuff that will stay with you as a computer science engineer in the long run. Just try to learn them from a practical standpoint. Solve all the problems you have in your standard textbooks because you're still in your second year, so you have time, right? So, yes, so this is somebody who's saying, hey, I've started my preparation last week. Any tips for me? Simple. You have 6 months. Just make sure you're spending 4 to 5 hours. I'm talking about an average student. If you think you're slightly below average, you have to put in more. If you're above average, you might have to put in less. 6 months, if you're dedicated to crack GATE, you can do it, right? But you have to be extremely disciplined. So you have to put in 4 to 5 hours every day, preferably morning 2 to 3 hours, evening couple of hours. Go through each of the topics very, very thoroughly. Most importantly, practice. Again, even people who say they prepare for GATE for 1 year, 2 years, 3 years, right? Their actual serious preparation is literally less than 200 days. Serious, when I say serious, I mean people who have been diligently putting in like 4 to 5 hours consistently with full focus. It's typically less than 200 days. That's roughly 6 months. Like I know, like even when I was preparing as a student, right? The actual dedicated days that I've put in, including my third year and my final year, probably is less than 200 days, right? So just be sure that 6 months, get away from all social media, get to work. It's as simple as that. Cool. Okay, Rishu has a question. He says, please answer. I couldn't find the answer elsewhere. What is the question, Rishu? Is it okay to pursue MSc from distance education to be eligible for MTech program in a different IIT? Yes, as long as you have a degree which is recognized by Government of India, which is recognized by University Grants Commission, which is the governing body for all higher education in India. Whether your master's degree is distance education or not, doesn't matter. You have a proper, because I believe for MTech, you need to have a 4-year bachelor's degree or a 5 years BS plus MS or BSc plus MSc. So perfectly all right, Rishu. There is nothing that's stopping you. As long as you have a degree from a university which is recognized by UGC, a master's degree, like an MSc in this case, you're eligible for GATE and entrance to MTech programs at IITs. I mean, they don't say which university you should get a degree from, as long as it is recognized by University Grants Commission or UGC or Government of India. Cool. Okay, sounds good. I think we have had a good discussion today. Thank you very much. Again, all the course participants will have the next live session on the coming Friday. For the general public, see you the coming week on Tuesday again. All the very best. Thank you very much.